Well, good day, ladies and gentlemen. Here is our review for quiz number 1. Now, two things you should note about this. Number one, the video of what I'm doing here will be posted on my YouTube channel. Secondly, the physical notes I will send to your Blackboard under content. I think in my last email I referred to something about Module 1. They redid Blackboard. There is no Module 1 that I could find. So I'm putting all the notes under content. So if you go to content, you will actually see these and you'll be able to run them off and use them on your quizzes. And you may use your notes on your test. So good thing to have handy is review for quizzes, run off for your quizzes and your tests. All right. Typical fashion, there's going to be just a few questions almost identical to the ones you will find in your problem sets. Here's our first example. Solve the following linear equation. Now, if you remember from our notes on linear equations, and if you haven't looked at the video or downloaded the notes, that might be a good idea. One good thing to do is to get all your x terms on one side, all your numeric terms on another. Doesn't matter which side, but let's go ahead and simplify this guy. First thing that obviously needs to be done is a little bit of distributive. So let's go ahead and take care of this step. Left side stays the same, but you know the distributive property. Multiply this by whatever is added or subtracted in the parentheses, 4x plus 16. Next step, combine my like terms. Always a good idea. Here's where some of you might notice that the left and right sides are identical, which means that we have something that I referred to in my notes as an identity. The notes page looks like this. The way you know you have an identity is eventually the left and the right sides are identical. And one thing that's true about an identity is it is true for all real numbers. So let's, if you didn't notice this, if you didn't notice that the sides were identical and you said, hey, I think I'll subtract 5 from both sides. And then you say, hey, I think I'll subtract 4x from both sides. Every identity always boils down to 0 equals 0. This is when you know you have an identity, if you didn't notice it here. And the solution set for every identity is all real numbers. So any number will work in this equation. Doesn't matter if I substitute 23.4 for x, or pi over 17, or negative 33.8. It doesn't matter what I substitute for x, I will get a true statement. So I have solved the following linear equation. And if you downloaded your notes, you'll know that there are 3 types of solutions. One is when I get a simple answer. Typical linear equation solves with one solution. I will get a contradiction, something like 6 equals 2, which of course is not true, which means there is no solution. And the third possibility is the one like we just worked. That is what we called an identity, which is true for all real numbers, i.e. there are an infinite number of solutions. So when you when you answer this question on Hawks, you're going to choose the option that there are an infinite number of solutions, or that the solution set is all real numbers. Easy enough. All right, solve the following linear equation. The one thing you'll notice about this guy is we got decimals. Now you can do this a couple of different ways. If you don't mind decimals, if you, in fact, decimals are your BFF, then you can just simply work it out the same way. Get the z's on one side, the numbers on the other, and solve. Or if you have problems with decimals, if they are a little bit intimidating, you may eliminate the decimals. And the way you're going to eliminate the decimals is ask yourself, how many places must I move the decimal place to the right in order to make real numbers of every single value and coefficient? In other words, I want every number to be a whole number. Well, if I move that, it's got 33, 27, 42. Hey, if I move it one place to the right, so if I move the decimal one place to the right, I'm going to have all whole numbers. Another way to think of it is multiply every term by how much? Well, 10 would move it one decimal place. 10, one decimal place. You want to move it 2 decimal places? Multiply by 100. Want to move it 3 decimal places? Multiply by 1,000. So I'm going to move every decimal place one move to the right, and I'll have a more conventional, hey, still the same equation, but it's in a more conventional form, all whole numbers. Hey, I got z's on both sides. I need to get z's on one side and numbers on the other. The numbers are already over here. Good idea to move the z's over here. Subtract 33z from both sides, and I get 9z's is 27. And you know what to do from here. I don't want 9z, I want z, so I'm going to divide both sides by whatever's in front of my variable. That gives me z. Don't put 1z, but just put z. Less confusing. Z is 3. Hey, this is what we called a conditional equation, right? Conditional equation has one solution. And my one solution here is z equals 3. Now be careful on your quiz. If it has something like this, and you're supposed to fill in the answer, do not put z equals 3. Even though that would technically be correct, that would give you an incorrect answer. If it already has z equals, just put 3. Another thing to note about your quizzes is that you have 2 opportunities on each quiz. If you should mess up on one, put in a wrong answer, inadvertently, and you go, doggone, I knew the answer. Hey, take it again, and the second time, make sure you get it right. And you will be given the better of your 2 grades. So, solve the following linear equation. Done. On this last one, we have a word problem. And that's what 2.1b is. It's applications of linear equations. And that is, another way to say that is word problems. And it says, find 3 consecutive integers whose sum is 537. A good idea here is to know what consecutive integers are. Always a good idea to know the definition of your terms. Examples of consecutive integers, 1, 2, 3, 47, 48, 49. Consecutive integers can be positive or negative, negative 28, negative 27, negative 26. These are all examples of consecutive integers. Well, I want 3 consecutive integers whose sum, and you know that means addition, whose sum equals 537. Now, your problem itself and The approach in your Hawks gives one approach to solving a consecutive integer problem, and that is to use n plus 1, n plus 2. That's okay. And if you're used to that, help yourself, go for it. But there is a variety of ways to approach this, and my suggestion is a more straightforward approach. If I have three numbers and they have a particular sum, then I know that the one in the middle is in fact the average value of these three. This one's one smaller, this one's one larger, this one's right in the middle. This is the average of my three numbers. So if I could find the average of these three numbers, I could find my middle number. How do you find the average? Well, you add things up and divide by however many you got. So I added these up. There it is. Divide it by however many I got. That's 3. And I'm going to use something that I highly suggest you use here, your very cheap $10 scientific calculator, which each of you should have for your quizzes, your assignments, and especially for your test. 537 divide 3, why that's 179. So I have just found the middle value, also known as the average. I've just found the middle value of these three consecutive integers. Hey, the one larger, that's easy. And the one smaller, got it. All right. So if you have three things added to get something, to find the middle value, just divide by 3. Hey, if you have 5 things, let's see here. Let's say equals 135. If you have 5 things added that equal 135, I can also find the middle value, which is the average, by simply dividing by 1, 2, 3, 4, 5. So 135 divided by 5. Notice the denominator changes based on the number of values that your number of consecutive integers you have. 135, let's see, 135 divide 5 tells me that's 27. So my middle value I have found as 27. That's easy. 28, 29. Lower than that, 26, 25. All right, so the number of values you have will tell you what your average number is by dividing your total by that number of values. Well, one other question here. What if you had 4 values? And let's see here. Let's say it equals 170. Well, my middle oh, wait a minute. I don't have a middle value. To have a middle value, I have to have an odd number of consecutive integers. I have an even number of consecutive integers. Well, I can still find the average. And the average is going to be right here in between the middle two numbers. So if I take my total, divide by the number of values I have, let's see what that tells me. Divide 4 equals, I get 42.5. So 42.5 is in between these two. So the one just larger than 42.5 is why it's 43. And the one just smaller than 42.5 is 42. And again, I have my 4 values by doing the same thing. Take the average. It will either give you the middle value if you have an odd number of integers, or it will give you the middle of your array, which is in between these two. So anyway, odd or even, you can still take the average and work from there. All right, once again, I'm going to post these physical notes on Blackboard under Content. Look for it there, and I will put the video on YouTube as review for quiz number 1. All right, good luck.